I don't know where the other ones are. Welcome back, everybody. We did not have any formal homework last night, but maybe, just maybe, we'll have some time to work on the homework while we're watching the game. How? Not sure how to interpret that answer. Not how was it, how do I do it? I should have asked a better question. Factor that bad boy. It's difference of two squares. How does it factor?
X plus 2.
I've got X plus 4 and X.
Yes, yes. Yeah.
Where would you simplify this one?
Oh,
How about this one?
7 of X minus 7. X plus 1.
Love it. Okay. So as we're looking at this, we're going to see today, we're going to do one more ugly one after this, just for the record. Do these feel okay so far? If you can factor, they probably feel a lot better than if you struggle with factoring. That's naturally going to happen. I did not forget about giving you guys something to help with factoring over the weekend. Just throw it out there. Because it's Thursday today, right? That. Okay. Check it out. We're going to see, we'll do this one and one more, and then we'll do an uglier one for a moment. But on this one, we've done the scratch work here. What does this allow me to do? When I rewrite this up here, and I'm going to try to not actually write my LCD yet, because I can see it here. Can I rewrite this expression with all of this stuff that I just did?
Yeah.
Now, whether I'd done this or not, could I have factored it and done the same? And I'll show you what I mean. The answer is yes, but if the question's not super duper clear, instead of writing 1 over x squared minus 16, what can I write at this point? 1 over... Yep, x plus 4 and x minus 4. Now, when you write this, I am very, very, very intentionally going to leave a big gap in front of this next number. The next one is x plus 1, and I'm going to make a little bit bigger of gap. X plus 1 over x minus 7 and x plus 1, right? Okay. Now, as we look at this expression, there's a couple of different routes that we can take. Right now, on the right side of this expression, I think I see something that's going to simplify. Can you tell me what's going to divide out on this one?
X plus 1.
The x plus 1's divide out. Now, notice I didn't say cancel, I didn't say cross them out, because when I divide out, it's really just replacing it with a what number? It's a 1, right? X plus 1 over x plus 1. So, if it's okay in your guys' work, what I would suggest doing, and again, notice we didn't really lock down our GCF here yet, I'm going to cross both of them out, and what goes in my numerator now? Not, it's not a 1. It's not a 0, I'm sorry. Dang it. What's x plus 1 over x plus 1?
1.
That's all that's left up here. When we divide it out, it doesn't magically disappear, right? Like, that's why I hate the word cancel. It's 1's out. It's a 1. Now, if you don't like that, if I had done it like this and said, what was the number in front of it? Do you agree it's a 1? Maybe that's how I should have approached it in hindsight. Okay. The whole point is, as I'm looking at this, and do you want me to rewrite it so I don't have the crossed out stuff? Okay. Without formally doing the LCD steps, because we didn't really finish it. What are the prime factors that show up in this denominator?
4.
Not just 4.
That's minus.
X plus 4, and this one only has the x minus 7, right? Instead of doing like really specific scratch work on the side, can we just think that LCD thing through right now? Let's see, my least common denominator, let's just check it out. It has an x plus 4 in it, because here's one prime factor. How many times does it show up in this list?
1.
How about that one? So the most number of times it shows up is once, means the LCD has it, right? Does this doesn't have an x plus 4 then, yet. Could we give it one? So, real quickly, oh, she gone. Okay, I'm going to write this a little bit nicer, and I can tell that I'm getting some, maybe not super clear. I'm going to rewrite this just without the cross out, so it's a little easier to see. So equals and equals, awkward space again some more. And now I'm just going to write it as a simplified version. Same thing, it's just a little nicer to look at. Okay, so check it. If I wanted to, and we wanted to go through and find the LCD, we could do it like yesterday. And if you're rusty with it, it's okay. I know there's 1x plus 4, because I just look at the prime factors and say which one, how many times it show up. Cool with that or not really understanding? Okay, so the LCD has an x plus 4. This one already has it. Does this one have one?
No.
Not yet. But what number can I multiply by that doesn't really change stuff? Can't be 2, 1, and any choice of 1, right? So this one did not have an x plus 4, but it needs it. Can I just multiply by a choice of 1 that includes x plus 4? And if I do, what has to be in the numerator?
X plus
And I agree with that. Why, Yell? Yeah, I just multiplied by 1. How did I know it had to be x plus 4? Okay, so that's okay. We're going to get it, and it's going to be obvious. It's a weird question right now because we're trying to skip steps, sort of. Help me out with this part. If I want to step further, what is the LCD or the LCM? Let's see what it has. What's one of the prime factors in either of these lists? So x minus 4. How many times here? How many times here? So the most number of times is 1, right? So this is what we did yesterday. Check. Sorry, I'll check it here. What's another prime factor? X plus 4 shows up once and none, so 1 time. Everybody still on board? Now, this is where it gets weird because if I simplified it first, I'm going to pretend as though this x plus 1 is already gone, if you'd like, or we can divide it out afterward. We'll divide it out afterward. And I will undo a bunch of stuff here in just a second. Give me another factor the LCD should have. X minus 7. And then, like I said, and I don't want to confuse you, and I hope it doesn't, but let's pretend that we didn't try to skip it. And I'll just show you we get the exact same thing. Okay. Any other common factors? X plus 1. Okay. Right here, before we continue on, does this feel okay with what we just did? Now, I'm making the claim, and maybe I didn't present it very well the first time. I think we can do this exact process in our problem without having to do like specific scratch work over here. But let's just see if that's what shakes out. So as I'm looking at this, we'll go back to our original, and I'm going to do the same thing that we started with a minute ago. 1 over, instead of x squared minus 16, I'm going to write x minus 4 and x plus 4. Are we still on board here? Okay. Plus, and I'm going to leave an awkward gap again. It looks like it was x plus 1 over x minus 7, x plus 1. Are we still okay here? Okay. Now, if we don't do the simplifying part right now, it's okay. We're going to have to do it later, though. So we'll just see the alternative here. Right now, if I know that my common denominator needs all of those pieces, what is this one missing? What isn't in the denominator that should be? So I have an x minus 4, right? And I have an x plus 4. What else does it need to be the common denominator, though? I have these two. I need 2 more, though, right? It has to have an x minus 7. And I'll make sure it's a clever choice of 1 here. And what else? And an x plus 1. Now, it gets a little bit uglier, but I just want to stress, what did I multiply by here? So kind of, but what is this?
1.
And what is this?
1.
So what did I really multiply by?
1.
Even though it's kind of ugly, right? Now, we didn't do the simplification stuff here. Help me figure out which ones are missing on this one. We have an x minus 7 and x plus 1. We need an x minus 4. And
X plus
the x plus 4. So the same thing happens here, though. And what I mean by that is, what did we really and truly just multiply by? It's just a really ugly way to do 1, right? Okay. Before we continue on, questions that we have.
So the shortcut is the 4 grid, right? The LCM is the same, right?
The what?
The shortcut, like,
That I did before?
yeah.
Yep, we're just going to have to simplify after the fact here. We're going to get the same answer.
Oh.
Guarantee it. Okay, so a little bit of algebra practice. I'm not going to distribute all these. Not a chance that you could even convince me to do this right now. I know that my denominator has all 4 of those pieces. X minus 4, x plus 4, x minus 7, and x plus 1. What I care much more about is the numerator. Now, we can multiply it, or we cannot right now. I think that we probably should. I'm going to give you guys a minute. I want you to do 1 times x minus 7 times x plus 1. You are going to multiply this 1. Sorry. Like when we multiply fractions just straight through, I want you to multiply 1 times x minus 7 times x plus 1. You're going to do a little bit of distribution or FOIL. We're just going to multiply right through. What do you mean it's that one?
Never mind.
X squared, right? Plus 1x minus 7x makes minus 6x minus 7. I believe you. You can add to it if you'd like.
I was talking about the one up there. The X squared and the original column.
Okay. Oh, I see. Yep, you noticed that it was the same thing.
Yeah.
Love it. Okay. How about the second piece? Is it as nice? Is it? This times this times this? Now, what's the easiest way to make this happen? Any ideas? Why negative 1? So remember, we're trying to make, if we do this, Kian, then we're losing our common denominators. And our goal right now is we need that common denominator. I know the whole denominator is just the same thing. X minus 4, x plus 4, x minus 7, and x plus 1. But what about the top? This times this times this. Can I move multiplication around? Like 2 times 3 times 4 is 2 times 4 times 3, right? I can move stuff. I'm going to use what Desi recognized a second ago. We have to multiply those two as part of it, right? What do these multiply to be based on what's written right above?
X squared minus 16.
Yeah, so right now the question is really x plus 1, this, and we already know that this turns into x squared minus 16. Because I just did these two first to multiply. Can we do this FOIL a little bit easier? So help me. What's x times x squared?
X squared.
Cubed. And this one?
Minus 6. Oh,
And it's going to look goofy. I'm going to put it here, and you'll see why here in a second. Next one? 1 times what? And that's x squared. Hence the reason that I left that awkward gap. And the last term. Good. Now, at this point, there are some time-saving things that we could have done. And I'm not going to give you like 40 problems a night, just so you know. Like if it takes us 10 minutes to do a problem, I would anticipate 3 to 5 of them, like realistically. As we look at this, do we have our common denominator? So if we have a common denominator, what can we do with the pieces? How do you add fractions? So yeah, we just add straight through the top. Does the denominator change?
No.
So what's our terribly ugly denominator right now? Can we just say it like, and I immediately changed my mind. Can we agree it's that? Instead of making you say it over and over? Okay, so here's my denominator. Let's just clean up the top and see what shakes out. Biggest power of x that you see anywhere.
X to the third.
So there's 1x to the third. So you gave me a good number, like you're right that that is the largest number. But if I want to write this in standard form, I'm going to do x third. I'm going to really lightly cross it out. I'm now going to look for x to what powers? So we have x squared plus x squared. What is that? Try again, because you just multiplied. X squared,
2x.
there it is, plus 2x squared. I'm going to cross out the x squareds because I've dealt with them. And I'm do it lightly. What's next? Negative 6 plus negative 16. Negative 22, what?
X.
X. So we'll cross out the x's. And the last little part. Minus 23, because negative 7 minus 16. Now, what we have in front of us might not feel super nice, and I get that. There is a way to factor this that's not going to be our focus right now. This answer, for our purposes currently, is fine with me. Now, when we're looking at these, what I wanted to do earlier, and it's okay if we didn't, is when we got to this point, I noticed that that would have happened, and it would have made our common denominator way smaller. It would have not had this in it. So it would have been a little bit easier to work. We would have gotten a different looking answer, but I will promise, and I can show you guys, and I'll do it during the basketball game when we put it back on, we would have gotten the exact same answer. Okay. We need to do one more, but we're going to go back to like 8th grade for a minute. Cool. All right. Do some 8th grade stuff then. So we've been adding and subtracting fractions, right? Well, let's do some more of those. So this last type of example that we're going to see today is going to be called complex fractions. And now, not complex as in the imaginary unit I or anything like that, just some complex fractions. Okay, we're going to check here, and if we need to do it together, we can. I kind of want to see where you're at with just the numbers, but no shade. You might be not loving it. So let's see here. Let's say it's in the numerator, we have 5 plus 6/7. In the denominator, we have 2 minus 4/9. I want to simplify this fraction. And here's what I need your guys' input. Do you want a minute to play around with it, or do you just want to start working it together? Okay. Why?
I just don't know where to.
It's so ugly that it can be super intimidating, right? But do you guys agree that there's a lot of fractions here, but is there a clear top and bottom of the overall thing? Do we all agree that this whole piece is the top and that this whole piece is the bottom? Okay, now here's my advice. I know it's gross right now and it won't be for long, but if we could make this feel easier, it'd be like awesome. So let's do that. Right now, I think that let's forget about this for the time being, because I think that we can probably deal with the top. This is really 5 over what number? It's 5 over 1, right? Like, and there's a million ways. You're not wrong if you say 2 because you're looking here, but this is really 5 over 1. If you want to add these without doing all the side work, can you tell me the least common denominator? Between 1 and 7. I'm not looking at the bottom at all. So they do both go into 14, but I think 7's first. Okay, my common denominator is a 7. This already has a 7. Do I have to change it then? Does this already have what I'm going to make my common denominator anyway? Does this one have it yet? So what can I multiply 5 over 1 by to make that happen? Be more specific, because I disagree at this point.
7 over
5, 7 over 7.
Okay, so real quickly, just everybody together, what do we multiply by that doesn't change it?
7 over 7.
1 is the correct answer, but this is 1, so that's also correct. 7 over 7. It's always a choice of 1. Forget about the bottom part still. And for those of you that can't see it, Jade and Deck, I'm covering this up with my hand for the time being. Okay, so let's do that. What does the numerator turn into? And when I say that, I'm talking the green top. 5 times 7 is 35 over 7 plus 6 over 7. And we'll even go one step further just while we're here. 41 over 7. Kian, do you agree with that? I saw that. That's why I called on you. Do you agree that this is 41 over 7? Everybody agree with that? Okay. I did the bottom part for you, or the top part, I'm sorry. I want you guys something very similar. I'll do this one in this lovely orange color. I want you to do the same thing. Now we're just going to ignore the top for a second. Make me a single fraction in the end here. And I'm going to give you that as well. It's 2 over 1 right now. Make a common denominator and combine them for the whole bottom part. Just like we did. I'll give you a second. So once we get here, we have a single fraction over a single fraction. Hella money is one thing that people have started saying, because it's the what? What do you do? What? Show me the dance. And why would I want you to be doing something like this right now?
Shortcut.
Flip.
What am I? There's a word for this.
Flip.
Turn around.
reciprocal. Okay. How many of you guys remember that to divide by a fraction, you multiply by the reciprocal? Okay. I think more of you probably do than just give me the heads up there. Can you tell me why? I know Ms. Jarvis showed you guys, oh yeah, we just multiply by the reciprocal. I know that happened. But why did we multiply by the reciprocal? Other than because Ms. Jarvis told me to. So how about besides that? What if Mr. Jarvis is lying to you? That was funny. Say that again?
So you can cancel the denominator.
Yes. Now, here's the deal. We're only going to do this one time. But if you've never seen this, and you're not really to multiply by the reciprocal, which is what the woe does, or what this does, or the hella does. I just want you thinking this. I don't even know the song. Hella money. I want to see why real quick. Only time we're going to do this. Moving forward, we can say because it works. But I want to see why it works. What do I want? Instead of 2 fractions, which is what we have, do you agree that 1 fraction is so much nicer? So if there were a way to make this turn into a 1 in the very bottom, like this 14/9, if it were 1, that'd be easy because then it would just be a single fraction. So here's a big question. What do I multiply this by to make it a 1?
9.
I multiply it by 9, and we're almost there. If I multiply it by 9, it turns into a 14. What do I have to divide it by to make sure that falls out? Not 9.
1.
If I do this, what happens? Do I get the same number here and here?
Yeah.
Now, here's the weird part, because that seemingly goes against what I've told you, right? We can only multiply by 1. That's not a 1, but it's about to be. I just multiplied the denominator. What do you think I should multiply the numerator by?
6.
Now it's a choice of 1, isn't it? 9/14 over 9/14. Anything over itself is 1. My denominator is completely gone. And what we do see is exactly what people want to happen. You take the fraction divided by fraction, and we just multiply by the reciprocal. But rather than just saying because we do, it's because it turns out that's the right choice of 1 here. Now, I want you to be able to multiply by it, but it's nice to see why it happens. At this point, how do we do it then? We just have 41/7 times 9/14. How do we finish this problem? What's 9 times 40? What's 9 times 4? 360, and then plus 9 more, so it's 369 in the numerator. And if you can't do that in your head, does that matter? Not even a little bit. You have calculators. I'll give you a calculator. That's fine with me. 7 times 10 is 70, and 7 times 4 is 28. You add them together, you get 98. This is my fraction. 7 times 14. Yep. And we're done. Now, we're done. That's the fraction. It might simplify. I'm not even going to bother checking because 369 in my head feels prime. I don't think it really is. I bet a 3 goes into it. But a 3 doesn't go into this. Should we do another one with just numbers? Or you want to bump it up? Did you say pump the jam? The beats are rocking. Oh, what's the next line? Oh, turn it up. Pump the jam. Yeah, the beats are rocking. Oh, there's another line there. You want a brain break real quick? This one. Do you remember doing problems like this?
No.
Yes.
I'm telling Miss Jarvis.
Oh.
I really won't. I assume you did it with Mr. I don't know. I wasn't in your class. Okay. Questions about this before we bulk it up a little? Okay. So we're going to do one more together, and then I'll have you guys do one more on your own or quasi on your own so that we can just see how it goes, like partially. Okay. So check it out. Let's do one more. I want 1 over x plus 3 divided by, let's make this one x plus 2 over x. That seems like a weird one to do. Now, it's really no different than what we just did. It feels about the same to me, but it might be a little intimidating. Can we still treat the top and bottom like they're their own things just while we're thinking about it? Okay, this 3 that I wrote, what's its real denominator?
1.
So if you want to do this, I would encourage it. This is really a 3 over 1, which means when I'm looking at just this just the numerator right here, up here, what is my common denominator going to be?
1.
There's a 1 and any other prime factors in the denominators. Mm,
Oh, no.
there's a 1. What's the only other thing in a denominator? X. This one has a 1 already, and it has an X. This one has a 1. Does it have an X?
No.
So does it need an X?
Yep.
So what's my choice of 1 to make that happen?
X.
Good. Now, I'm going to go one step further. Before I move on, if we look at these two, 3 and or X and 1, the only way that they meet is at X. Now, we could do the LCD and we could write it all out and say, here's the X and here's the 1, and let's make sure they both have it. But we're just going to get here right away. Now, I'm going to suggest a way to save a little bit of time on these problems. What's the common denominator going to be up here? And then this is going to be 1 plus 3x. So I think, and correct me if I'm wrong, I think that I can just say pretty confidently that this changes to 1 plus 3x over what? X. Good. I want you guys to do the denominator for me. Find me the common denominator down here, and I'll do it in green or whatever. I want you guys to do the same thing right here. I will give you a moment. If I do over 1, and like this is where I saw you guys doing it, and Desi, you were not confident in it. You should be, just for the record. Do we agree the common denominator down here needs to be an X? This already has it. This doesn't, so I'm going to do that. Now, I'm going to do the same thing in 2 steps. Let's just clean up this first part. What's X times X?
X squared.
Over
X.
X. Plus, the other part is
2.
over X. Now, here's where I want to pause because I want to try to save you guys some time and some writing. Can you tell right here when I do this that we're going to have X as a denominator in each of them? Like, that's the whole point of doing that, right? And I can write it like this, and that's all fine and dandy. But without you telling me that that's what's the denominator, can you do you agree that I can see it's X squared plus 2? And notice it's X squared plus 2. If they're both going to be over X, they're just going to shove together, right? I have no issue. If you're comfortable skipping this middle step, you can do it. Like, it's not a huge leap. If you can find the common denominator, you have everything that you need. But here we are. This is what goes in the denominator then. X squared plus,
X.
how do we add fractions? Good. Over X. Now, show me that you hella understand real quick. And I'm doing this because this is how I do it, or the hollow O if you'd rather. How do you divide by a fraction?
Keep change foot.
I think that sounds right. I don't know exactly what it means. If that means do this. Okay. Is that a different way to say multiply by the reciprocal? I don't really understand that language, but I'm good with it. What am I multiplying by then? Okay, are we done? Okay, not quite, but we're close. When we're looking at this, really important idea here. I don't put the parentheses, but are there parentheses around this? Does grouping count with ugly fractions? So good call. If that's a gut feeling, you're right. It does. There are parentheses here, whether we write them or not. Grouping happens here. Now, that means if we wanted to multiply, we'd have to distribute, right? But before we actually do that, let's just hold off. Do you agree that in the top, I can see that I'm multiplying by X? And if I look at the bottoms, because I know they shove together, am I also dividing by X? So I have, and if we want to write it, we can. I don't think we need to, but it's going to make this super clear. In the bottom, it's going to be X squared plus 2 times X, right? And I'm going to change the order for a very specific reason. Now, this is more of a in my head sort of thing that I would typically encourage. Why did I write it this way? What did I really want you to know this is going to happen? So they do get multiplied. Does anything divide by itself? We have an X divided by X, don't we? What happens with them?
Just 1.
Yeah, it's 1. They won out. They divide out. Now, what I would encourage, if you have to come to this line to do it, I'm fine with it. No issue. And I would strongly encourage, I would rather just do it here. I can see that I'm going to multiply by X and I'm going to divide by X. Let's just get rid of both of them. At this point, whether it happens on this line or on this line, we're done. What is the ending addition here? I said x squared plus 2x. I don't know why this x tacked on. I'm going to erase it. I don't know where it came from. I didn't notice I wrote it until just now. That shouldn't have one. I don't know why I got one on that line out of nowhere. There's no x connected to that. I'm going to erase mine. All right. For this, these things take practice. They're kind of ugly. They're clunky. But because I want you to practice and make sure that we're cool with it, I'm going to give you that practice time right now. While you're practicing, remember, and this isn't like a bad thing, I'm going to give you 4 factoring problems every weekend. Like, until everybody can do them consistently, like, solid. And it's not a bad thing, I promise. I just want you to get better at it. If you're already good at it, cool, you'll get better. If you struggle with it, cool, you'll get better. Like, we're all going to benefit. All right, so for tonight then, I'm going to give you a pretty chill assignment to start working on now. And let's see if I wrote it on first hours. I did not. Bummer. All right, so let me grab a textbook. How many problems do you want?
One.
1?
3. 1 times 5. 4.
Not 6. 7? All right, so your homework tonight, and I'll put it on Google Classroom here in just a minute, and then I'll get you guys your factoring stuff. Your homework is going to be, and it's weird because we skipped a section because it makes more sense in my head to talk about addition and subtraction before multiplication. We're going to call this homework 4.4.1. And we skipped a section, but we'll come back and do 4.3 after this. You will find this waiting for you lovingly on page 210. 210. And I want you guys to do 18 through 23. And even. I wouldn't give you 18 if it was odds, just so you know. Okay, I probably would because I've done that before. I will try not to, but it's 18 through 23 all. 6 problems. 6 problems. It might be 8. It's 8. Is it? No, it's 6. 18, 19, 20. Yeah. No, see.
Oh, 8.
Yep.
Count 8.
So check this out. You guys want to see the weird thing that it's not really that crazy until the first time you think about it, and you might have had this thought. When I stop talking, I'm going to let you guys count to the count of 5. Like, do it in your head, and I want you to clap when you get to 5 seconds after I'm done talking, okay? We won't look at a clock. As soon as I stop talking, in your head, count 5 seconds. Everybody ready? So I'm going to stop talking. In your head, you're going to count to 5, and after 5 seconds time has passed, I want you to clap, okay? And I'm going to stop talking right now.
I have 3.
You and me were close.
Wait.
Show me out loud. I want you to count 5 seconds out for me.
Oh.
Like, let's just, together, on the count of 3, you're going to start counting out loud. You're going to count to 5 seconds. Start.
1, 2, 3, 4, 5.
Okay, so a couple weird things. First of all, you all did the thing that's going to blow your mind here in a second. If I count, your timings are all off, just so you know. If I said, let's just count to 5 seconds, you might go 1, 2, 3, 4, 5. But here's the issue. How many seconds did I actually count? I went 1 to 2, 2 to 3, 3 to 4, and 4 to 5.
Wait, what?
Right? If you start counting, if I started a stopwatch, what time does it start at?
0.
So why do you all start counting time at 1?
I started at 0.
I also start at 0, but it's pretty rare that people do that. If you want to count to 5 seconds, you don't go 1, 2, 3. Don't do it like that, because you're going to get 4 seconds. You go 0, 1, 2, 3, 4, 5. You have to count the 0 to 1 second first. Otherwise, you're never going to count it. Just a random thing. Lucy and I, we're both the closest. We win. All right. Time for your homework. Do it to it.